Oh, there we go. Let me introduce you to Baruch Savagorski from JFrog, DevOps for developers, or maybe against them. We all love DevOps. So I'm going to stop sharing the screen. I can get the mouse over. I don't know where my mouse is.
All right, Vince, thank you very much. I will share my screen so you will see my slides.
We need you to stop sharing first, and I can't get my mouse over there.
Let's see, I think I can just kick you out.
Yeah, there you go, good deal.
Yep, that's what I did, easy.
Perfect.
All right, now you should see my screen and devs for developers or maybe against them, right? As Vince mentioned. And I think, you know what? Let's start with a poll. Let's start to know you. So I'm going to launch this poll. We'll give you like 20 seconds and we'll see who are you. I think I have a pretty decent idea, but let's see if I will be surprised. Yeah, okay. That looks like as expected. Okay, so we have 43 people online. I have more than 30 answers. That's fair enough. Okay, so take a look. As expected, the majority of you, 91%, are developers, and this is great because you're here to learn if DevOps is actually against you. And I have 3 DevOps engineers, and you are going to be especially delighted by this talk. All right, okay, so you are developers. Let's talk about stuff. So first of all, apparently no one knows what DevOps is. You can see here people get jobs in DevOps as DevOps engineers, and then they think about maybe it's a good idea to go ahead and ask what DevOps is. That's pretty much where we are. 10 years of DevOps, still no one knows what it is though. My name is Baruch Sadogurski. I'm the Chief Sticker Officer at JFrog, also Head of Developer Advocacy. This is why we're talking today. The most important part of this slide is my Twitter handle at JBaruch. And this is my California disclaimer. Being from Silicon Valley, I'm very prepared in terms of disclaimers and this kind of stuff. This is an amazing chart from an amazing book called The Culture Map by Erin Meyer. Since all of us work in multicultural environment, I recommend you all to read it. And you can see on this chart that the most emotionally expressive and confrontational people are from Israel and Russia. And I managed to be from both. So if I offend you during this talk, I'm not sorry. If I didn't, I'm sorry for not offending you enough. I'll do my best to live up to the expectations. All right. So this is the most important slide of today's presentation. If you go to jeffrog.com/, show notes, not now, but after the talk, you will see there that I've already uploaded the slides. We will, we will upload the video once it will render by Zoom. All the links to everything that I will mention today, including, by the way, the culture map that I already did, are there. A place to comment, to rate, and also a very lucrative raffle to you to participate. I will elaborate a little bit about the raffle in the end of the talk. Please note that the URL for this page is on the bottom of every page, on every slide. So whenever you decide that, oh, I need to remember that, just remember this jeffrog.com/, show notes. Also my Twitter handle and the Twitter handle of Atlanta JAG, our today's host. All right, so what do you need to know about me, except of being Israeli and Russian, is that my roots are software developer. Not only software developer, Java software developer. I'm a Java engineer, as much as each and every one of you, but I also now work, But I also now work in the company that lives in the DevOps space and do tools for DevOps. So this is how I can actually speak about what DevOps is, and is it a plot or is it against us, the developers, from the inside. Consider me like an inside spatial agent that figured it out and going to share the information, whistleblow if you wish, on DevOps for developers. So frankly, whoever thinks that DevOps is a plot of ops people against developers has a very, very valid reason to think so. Let's look at the proof that it is actually that. This considered by many one of the most important books in the DevOps space. This is actually a novel in which there is a low-tech organization, car part manufacturer, that they have a very, very hard time getting into the digital transformation, and then they kind of invent DevOps and they win by using DevOps. So this is kind of the book that describes how DevOps looks like. Let's look at the cover and see who are the main characters of the book. They are very conveniently pictured on the cover. So you can see here Patty. Patty, I'm going just from left to right. Patty, she's director of IT service support. She's obviously an ops person. Ves, he's director of distributed technology ops. He's a director of ops. He's an ops guy. Sarah, sales and marketing, and then Steve, the CEO, Dick, the CFO, that's fine. Bill Parmel. Now, Bill, he's the main protagonist. He's the main character, and he is VP of IT Ops. The person who invents DevOps, transforms the entire organization, and wins through DevOps is an ops guy. There is Eric, who is a board of directors. Brent, this is the main technical person in the entire book. This is the technical protagonist, and he is lead system administrator. He is as technical as ops as you can get. And there is John, who is the chief information security officer. Now, who is missing? This is very telling. The only function which is not present on the cover of the most important book in DevOps, and also almost never mentioned in the book, are developers. Okay, let's look at another book. This is kind of also one of the most important books in DevOps, and this is the DevOps handbook. This is a practical instruction of how to implement DevOps. Let's look at the authors of this book, who wrote it. So you can see the first is Jim Keen. Jim Keen is the guy who wrote the Phoenix project. So we already kind of know what to expect from him. Let's look at others. Patrick Dubois, the person who actually invented the term DevOps. Amazing, very smart guy, was system architect. System architect like and system administration architect. He's an ops guy. Jez Humble, one of the greatest. He's the author of the continuous delivery book. He actually brought continuous delivery into our lives. Also, deputy director of delivery architecture, delivery ops concept. And the fourth, John Willis, again, like a giant, one of the co-founders both of DevOps and DevSecOps. He was working back in the day in a company that's called OpsCode. Again, very, very ops-related technology. So you see, they're all from ops, people who preach us about DevOps. Let's see who tries to explain DevOps to us when we search for what in DevOps in Google. So you can see the first result, New Relic. New Relic do observability, ops technology, ops company. Then we have Amazon Web Services, obviously ops cloud provider. CollabNet, this is the exception. They have some dev-related tools as well. But then again, the Agile admin like in system administrator. And then Wikipedia, okay. Atlassian, obviously very ops-related company as well. And then Azure is like, again, an ops platform. And then you can see over the battle, Logs.io, login company, ops-related concept. So wherever you look, whatever resource you pick up, you will see that the people who invented DevOps and preach DevOps to us, the developers, are all ops. Okay, the next question is why? Why do they try to, why they came with the concept of DevOps and why they push us, the developers, into DevOps? So first of all, let's see what is it about. So here's the question in Quora: how do I switch my job from system admin to DevOps? And this is the top answer, I think. And you can see here, basically it goes like, well, you need to learn a bunch of things. So you need to learn Linux fundamentals, you need to learn DevOps fundamentals, software development lifecycle, and then look at that. Here, number 6, you need to learn JITs, okay, whatever JITs is. So basically you are a sysadmin, and then you learn JITs, and next thing you know, instead of being system administrator, you're now DevOps engineer. You earn 50% raising salary just by learning JITs, which is a good deal in my book. And you know what? HR agrees with that. You look at the results for DevOps engineers, you see crazy numbers. 15,000 results for DevOps engineers in the United States. This is insane. But obviously, this is not why DevOps was invented. It's the reason it's not there. This is the result. The result is that mostly the recruiters saw this new term and then hyped it into sysadmin plus, into a more advanced sysadmin who also knows JITs. But obviously, you know what DevOps is. This is DevOps. This is the infinity loop of DevOps. This is how DevOps should be approached. You can see here that it's a methodology that includes part that the dev does and part that the op does, but kind of glued together. Now, for us, this is a very familiar diagram. It really looks like something that we know for 20 years now. And this would be the infinity loop of Agile. What actually happened when DevOps was invented is that ops people, as we already know, took their part of the job. So we have this plan, design, develop, test, release, but they also added on top of that, deploy, operate, monitor. So they took their part of the job, all the ops, all the ops work, and glue it together and gave it to us, to developers, and said, okay, now go ahead and do it. Now, I have another proof. Let's look at the State of DevOps report. And this is, again, one of the most important documents in the DevOps world. Everybody are talking about this report, and it's really amazing. It's a very thorough, very scientific report of where the industry stands in terms of DevOps adoption. This is not the last one. We already have 2019. That's the previous one, 2018. But I want to start with it in order to prove a point. We will get to the 19 edition later. So let's look how DevOps is measured in the State of DevOps report, or was measured last year. So you can see stuff that they care about. How do we deploy code? How we go from code, everything that after we finished coding, and further. Unplanned outages, degraded services. They measure concepts which are completely foreign to us, the developers. I mean, unplanned outage is not our job. Let's look what they call their job and our job. So obviously you can see here the main point of DevOps adoption is to produce more new work, because new work is where money is, where new features are and everything else. So let's see what types of work are defined in the DORA report, the state of DevOps support, and also in the Phoenix project, they talk about the same concepts. So planned work is the new work, is the new business projects and new features. This is great, and we relate. Internal project, server migrations, software updates. How, since when server migrations, it's something that developers care about. And then we have, okay, changes, that's fine. Unplanned work, support escalations and emergency outages. Again, we write code. We have nothing to do with outages. So it's all very nice. It's all very cute. It's important for us to understand the report, but it's really not our job. How our job looks like? Well, we have new features. We either do that, or we fix bugs, or we do refactoring. This is all the work that the developers have in their space. Server outages, server migrations, degradations, this is not ours. But what you just saw is that the ops people invented this term, DevOps, and then force us, the developers, to do their job. And I think I just proved it very, very clearly. Everybody can understand. Now let's talk about what is our job as developers. So I think one of the great examples of how a real software developer should go about what their job is actually Manifesto for Software Craftsmanship. You can see here how there are concepts that I have no doubt everyone agrees among us, right? Not only working software, but well-crafted software. Of course, we care about the quality of our code, not only responding to change, but steadily adding value. Obviously, we want to do the right thing. Not only individuals and interactions, but a community of professionals. Obviously, this is why we're sitting here. We now, you and me, this is this community. Not only customer collaboration, but also productive partnerships. Yes, we need to be in partnership with ops, with QA, with product. We don't deny that. It's a partnership, does not include taking their job and dumping it on ours. So let's take some practical examples of what those means. And one of the nice examples of this, of the software craftsmanship being put to a very concrete terms, is a great talk by Anton Keaks from the JPoint conference in Moscow a couple of years ago, called Becoming a Full Stack Developer. You can see what they're talking about. Full stack refers to the collection of technologies need to be complete by your project. Polyglot developer, you apply the right tool, all this kind of stuff. And then as a last item on the list, there is something actually related to deployment. Also deployment, you don't want to be called during the night. So, well, yes, it's a partnership. We want to help our sysadmins not to wake up during the night, but we do it for them. It's really not a part of our definition of done. Let's look what is our definition of done. So we understand what needs to be done, obviously, and our code is readable, simple, understandable, yes. Our code is easy to deploy, of course. We have partnership with the ops people that need to deploy. We want to make their life easier. This is why our code is easy to deploy. Non-functional requirements are met. We didn't incur any technical depth, and our test pass, and the head of QA took a look and they're happy, and the team took a look and they're happy. This is all the code reviews that everybody are doing. Product owner took a look. This is our collaboration with the customer. So in our organization, the proxy for the customer is the product owner. They look, they're happy, we're great. So it means that a client took a look and they're happy. Now, there is something else that Anton mentioned in this talk. And this is that it used to be a rivalry between developers and testers. And when I watched his talk, I agreed with most of the stuff he said, but I definitely disagreed with this slide. And I wanted to ask you, what do you think about that? So for me, I'm going to launch this poll, and then let's see what you say. And I will tell you my opinion on that, why I think it does not exist. Okay, 75% is good. I'm going to share it with you. So you will see that 70%, the majority, the huge majority of you actually think that this rivalry does not exist. And I agree. And I think that it does not exist because we, as software, as craftsmen people, right, we have the same goal of providing higher quality. And the QA is a service given to the engineering, given to the developers to help us, the developers, raise the bar of the quality. Because quality, just to remind you, is one of the pillars of our definition of done, is one of the pillars of our of our craftsmanship. So obviously we care about quality, and I promised you I'm from Russia, so you will get some Russian memes. Here you go. So quality is important. Now, what's interesting is how do we measure quality? And I think that things changed. I was an engineer quite a while ago, and when I was an engineer, I think the quality was something else that it is now. So let's go back in time and look at the Chase Bank website 10 years ago. 10 years ago, I think. This is how it looked like. You could log in and do something, and there is like the stream of news and announcement. And none of us would be surprised 10 years ago if we saw here an announcement that says 20 hours maintenance for update. We would go like, well, okay, that's fine, that's reasonable. They want to ensure quality of their website. They want to fix some bugs, maybe security vulnerabilities, and they want to ensure quality. They need to do an update of 12 hours. That makes sense. Obviously, today, that's not the case. None of us would accept their bank website being down for 12 hours to ensure quality. Not only that, today we will go as far as switching banks, which is a very powerful procedure for whoever you tried it, and I bet the majority did, over a usability or a quality or a stability of a website or an app. I did it. I didn't like the app. I switched the bank. So this is how the concepts of quality changed, how little we tolerate mistake those days. From the other side, ensuring quality is also much harder because code quality, just making sure that we have unit tests and integration tests and all those tests is not enough, because the amount of data that we face already today and will face later, and you can see here the size of the global data sphere is amazing. In 2020, it's about 2020, where is it? Yeah, 45 zettabytes. Zettabytes is a lot, is not after petabytes, it's after exabytes. It's a really a lot of data. And that means that more and more companies have so much data that establishing a staging server in the terms that we used to know it, and that's parity with the production, let's build a staging server and it will behave like a production server, is not economically or technically feasible. Google cannot have a staging environment which is exactly like a production environment. Nor Facebook, nor Netflix, nor more and more companies, even those who used to be able to do that, cannot do it anymore. So if we cannot ensure that we have staging, how we can ensure quality in production? And the answer is, well, we go to production and we start testing in production. You can see here a lot of buzzwords and techniques that emerged in later years that do exactly that. Stuff like canary deployments and control rollouts and feature flags and progressive delivery, observability. All those are about how we go to production in something with something that we are not 100% sure about the quality because we weren't able to create a staging environment in which we can ironclad test everything. And I think my favorite term on this cloud is blessed radius. Blessed radius is amazing about how vividly you can picture what happens when you release software. So you kind of throw something in production and it will explode, and you hope that you will be able to reduce the blast radius and reduce the casualties by doing, for example, progressive delivery or canary deployment. That's a very vivid picture. Now, what it actually means, all that, is that the only place we as developers can be sure that we did good with quality is production. And since, as I mentioned, quality matters to us, quality is a part of the things that we care about, suddenly we care about how our software behaves in production. And the only way to know how our software behaves in production is to being there when our software is released. And that means that we need to be on call, because now when something go bump and we have blast radius and we have casualties, we need to be there in order to deal with our concern, which is quality. And this also changes our definition of done. We have one more item to add to this list. SRE took a look and they are happy. Who are those SREs? SREs are site or now service reliability engineers, and those are those sysadmins plus that some people mistakenly call DevOps engineers. Those are the people who took the reign from system administrators, and now instead of replugging the servers with the network cables and then logging in and make sure they're tuned as possible, treat operations as a software program, use stuff like infrastructure as a service to be able to provide the needed infrastructure for our software to run. And what do they need, those SRE people, from us, from the developers? Well, they come with a list. We need to understand how our code is going to be deployed. As we mentioned, we need to be able to deploy it. The build is reliable, repeatable, and fast, because remember, we have a situation out there, blast radius, casualties. We need to be able to build a patch as soon as possible, and our build should be reliable, repeatable, and fast. Our code need to be able to scale. Again, we have a blast radius. Our servers do not cope. We need to be able to scale elastically. Our code need to be able to do that. Our code starts and dies fast for the same reasons. Now there is a blast radius. We need to roll back. That means that we need to shut down the misbehaving servers and then pop up old servers that actually work. That should be as fast as possible. Our code is observable. We need to know that there are casualties there. And hopefully, if we do the observability right, our observability will be able to roll back automatically using fast tear down and fast startup again. Our code supports feature flags. Sometimes it's easier just to turn off the misbehaving features by using the API. We need to be able to support that. our code is both backwards and forwards compatible. And this backwards compatible, obviously, because now old customers might use new APIs that we just got updated, but also backwards. You remember, if you rolled back, we might end up in the situation when new clients should actually be able to talk to the old APIs. And our code emits event streams so we can implement observability and know it. Now, this list of requirements, again, reminds us of something. And it reminds us of what is called the 12-factor app. And this is kind of another manifesto which talks about how to build applications for the cloud-native era. And those are the same concepts that SRE cares about in order for us to provide software which we can ensure quality in production. It's been a while since the 12-factor app was released. There are more factors that you might want to consider. And since then, there are new books like Beyond the 12-factor app from Kevin Hoffman that speak about what else is missing. In the end of the day, you will come up with the list pretty similar to that. There is another requirement, and this is that our code is lean. And by lean, what their SRE people mean is that our code wastes less resources and thus less money. And here again, you might ask, well, okay, I understand how quality is important, and I understand how you drag me to production in order to observe the quality, but this saving money has nothing to do with me. There is your AWS bill, and it's huge, or it's small, it's complicated, or it's simple. It has nothing to do with developers whatsoever. You want better servers, you pay more, not my problem. Well, apparently it is. And here's an example. Kafka Summit last year, a talk by Uday Sagar from SignalFx speaks about how by implementing Kafka and tuning it up correctly, they, SignalFx, manage to achieve 50% reduction in network costs. So suddenly, the decisions that we make in our code, in the dependencies that we use, in the tools that we use, affect the bottom line that our SRE are responsible for, but obviously it's the interest of the business. Now, suddenly, not only the production is our headache, but also money. And those are great news, because next time our boss starts to talk about cutting costs, and in the end, previously, the only ways they knew how to cut costs were layoffs or, saving on coffee machines or whatever. Now, suddenly, there are new concepts. For example, we can switch to serverless, we can move to the cloud. There are decisions, our decisions, the developers, that can affect the bottom line. So next time someone thinks about layoffs or paying for coffee, instead we can reframe the problem and actually start using our engineering tools to achieve savings and to make sure that our code is lean. Not only that, when we are now considering business concerns, what are business concerns? We need more happy customers. How do we achieve happy customers? The customers want features. When do they want them? They want them yesterday. And suddenly, this is what DevOps promises the business. Because if you look at the DevOps report and you see how the organizations which implement DevOps differ from organizations which did not, you can see that they deploy 2008 times more frequently, and the deploys are 106 times faster, and this is how they bring features to the market. So DevOps now not only provides us with the quality concerns that we have and provide business with the savings concern, it actually affects the profits directly when they allow us winning over competition. And it's the same with security, right? How did you do security privately? We hired a chief information security officer just for someone to take the blame when the next security breach occurs. But actually we can do better. And if we think about security and we think how the security is built, what are the forces that provide security? As for example, when you learn to drive and you thought about stopping distance as a combination of thinking distance and braking distance, concepts which completely different mitigations. For thinking distance, for braking, you replace your brakes and you pave better roads. For thinking, you replace humans with machines. The same way, when you think about security, there are three parts which are completely different. You need your hackers to identify that you are under attack. You need the developers to fix, and it will usually be just updating the dependencies. And in the end of the day, unless you can update your software faster, and this is DevOps, you won't be protected. And you can think about examples like Equifax. It took them 2 months to update their struts dependency. And next thing you know what happened, you know the aftermath, you know everything, just because they didn't implement DevOps, they didn't know how to deploy code to production faster. And if you think that probably you are not Equifax, you will be more agile in protecting yourself, well, I have bad news for you. Some of the modern threats like Spectre and Meltdown are impossible to defeat. They are inherently zero-day. You know about them only after you are under attack. And then this is critical. The faster you deploy code and the more frequently you can do it, this is how you get more security. So basically, DevOps is an evolutionary pressure. Yes, it is. The ops people came with it for their own reasons, but in the end of the day, the entire organization and us, the developers among it, need DevOps to succeed. So DevOps is a mean to an end. It ensures quality, it ensures savings, it ensures new features faster, and it helps with security. So it doesn't matter if we love our sysadmins or hate them for inventing DevOps for us to deal with, we have no choice. DevOps is here to stay because it helps the organization. So we're back to this diagram, to this infinity loop. And now when we know that we have to learn to deal with it, this is frankly quite frightening. Because if we all know the left side of the diagram pretty well, this is, in the end of the day, Agile, we live with it for 20 years, the right side is foreign to us. We are not sure how to operate and deploy and do this kind of thing. And diagram like this doesn't really help. Because when I look at this tiny triangle in the middle, this is quite frankly terrifying. What are the chances me, Baruch, who wrote code his entire life, will be able to master not only the development, but also the QA, the operations, and now the security and the product, and be expert in all of that? How that's even possible? The good news are that this is not necessary. Just because those people who actually master in all the concept, they do not exist. They are exactly like the unicorn farting rainbows. There are mythical creatures. And this is why the term DevOps engineer doesn't make sense, because there is no such creature as DevOps engineer. DevOps is about collaboration of different people with different expertise. DevOps engineer is a collaboration engineer. There is no such thing. What do exist are, and what we all need to strive, are the T-shaped people. Those are the people who still have their own deep specialization, and they are developers. This is what they do best. But they also know a little bit about QA. They know how to test their software. They know a little bit about operations. They know how their software will be deployed, and all that for the good of the entire team and for the entire organization. More good news, not only we now realize that yes, DevOps relates to us as the developers, the ops people also realize that DevOps is not only about ops. And this is the latest State of DevOps report that we have from last year. And you can see how the attitude changed. Now, the majority of the participants are actually development or engineering. And you can see how metrics changed. Now, software development is a very big part of the metrics that contribute to the success of DevOps. And not only that, the same author of the Phoenix Project, Jim Kim, released a new book, which is called The Unicorn Project, which is an alternative reality to the Phoenix Project. It's the same organization, it's the same struggle, and they still win in the end with DevOps. But the main protagonist, the person who, if you wish, invents DevOps and saves the entire organization, is Maxine, and she is a developer. What a change from not a developer inside to the main character, the main protagonist who invents DevOps and wins. Now she's a developer. And those SRE people are actually much closer to us, the developers, than the old sysadmins were, because SRE is about treating operations as a software problem. We are the software developers. Of course, we know and love software problems. So this, the mythical creature that knows both parts, it's not required anymore. Instead, we need to know software, and software now both is dev and ops. This is DevOps. So in the end of the day, good news, everybody. Yes, DevOps is an ops idea, but the business likes it because it provides quality, it's lean, provides competitive advantage, and it provides security. And it is actually not bad and not frightening at all, because now everything is a code, and we, of course, love code. So all we need to do is follow the principles and practices, and this is something in software developers us know how to do. So in the end of the day, DevOps is okay. It's actually more than okay. There is nothing to be afraid about, and we definitely should embrace this thing. So with that, Twitter ads. I'm AJ Baruch on Twitter. This is Atlanta JAG. When you praise this talk, don't forget to mention our great hosts. DevOps is the hashtag of DevOps. Guess what? And the show notes, as I already mentioned, great, amazing. So yeah, the slides, the video, a place to comment, a place to the place to comment, the place to rate, and the amazing raffle. I have here Ari, the meetup manager, here with me from JFrog, and he's going to talk about the prizes, because I don't know what the prizes are. Right?
Thank you, Baruch. I appreciate that. Well, I just wanted to thank everyone for coming tonight, and thank you, Baruch, for the talk. Just a couple things. For our May sweepstakes at JFrog, last month we gave away a few Nintendo Switch Lites, and we decided to do the same this month as well. At the end of May, we're going to be raffling off 2 Nintendo Switch Lites, and you can reach the raffle form by going to the show notes page, as well as clicking the QR code where Duke is hanging out, and we'll be happy to give you that. But and that's for anyone that attended any of our events in the month of May. For any of the meetings we sponsor. But that being said, I also wanted to ensure that we gave some quarantine cheer of some T-shirts away for the Atlanta Jug, which is very special to me. I'm Atlanta-based and love it here, and I wanted to see if anyone that joins that raffle, we're going to select. How many people we have here tonight? We're going to select 4 winners tonight that we're going to send them our newest Iron Frog t-shirt, which wasn't ready for DevNexus this year, but we'll send it out to you. So feel free to enjoy that as well. Thank you.
Yay.
All right, Baruch, thanks very much for doing that. Ari, thanks very much. Everybody, thanks for attending. And looks like next month we'll be virtual as well. So see you then. Stay safe out there.
Take care, guys.